In this film, we will go through the life cycle assessment parts that is called system boundaries, allocation, and impact assessment. If you remember the methodology of LCA, that is very simple in theory, but a little more complex in practice, we started to discuss on system boundaries, how that is made. The system boundaries must be defined in different ways. First of all, it needs to be defined in relation to the natural systems. And that means that you have to decide where your life cycle starts and ends and how much that is included in it. Does it start with the production of the material, or does it start with the mining, or does it start with the production of the material for the mining, etc.? And where does it end? The other decision you have to make is the boundaries in relation to other products' life cycle. That is when some parts of your product is used in the next product production. You have also to decide the geographical boundaries. Is your product that is produced, for example, in Europe, can that kind of data be used in the United States or in China? Where is your analysis valid? You must also decide during what time frame that this study is made. It is important not to compare a totally modern product with a 10-year-old. The production methods have been completely different. And finally, you must also define your boundaries in relation to capital and personnel. And that can be, for example, do you include in your analysis when the personnel goes to work in their cars or in buses? And do you include when they eat their food and the production of the food that they eat when they have their lunch breaks, etc.? We will start by giving an example of a comparison of 3 different systems of using glass bottles for beverages. In all cases, you have a production site, a glass works. And to produce the glass, you need different material: sand, lime, feldspar, soda, dolomite, and natural sulfur oxides. All these parts shall be transported into your glassworks, and all these must be charted and analyzed. And then the bottles will be transported to a filling and distribution center where it's distributed to the customer. And after this, you have 3 different systems that should be compared. Before you do that, we need to assess also from the glassworks there is some waste heat that needs to be treated in some way in the analysis. 3 ways for the distribution center. In the first scenario, you transport the used bottles and scrap it, use it as landfill. In the second scenario, you transport it and you collect it in those kind of glass igloos that we have in Sweden. Collect it, crush it, rinse it, and then go back to the factory and is remelted into new glass. The third scenario is that you, after you have consumed the beverage, you collect it, you transport it back to a washing station and reuse the bottles once again. To make this analysis complete in this scenario, you need to consider the production of the washing material, the detergent for this, and also some more heat when you wash the bottles. Sometimes then you need to allocate, if you have different products or different products that you need to allocate the environmental impact from. The methodology for this is clearly stated in the ISO standards 14040, where they recommend primarily to try to avoid allocation by system enlargement. Otherwise, you can use some physical connections between the products. You can use economically based allocation, or you can use some other relevant ways to allocate the environmental burden on the different products. And I will go through the different ways to do this here. For one example then is that you have waste heat that you can use for district heating in the system. And how should this be treated in a life cycle assessment? How can this be allocated between the three different scenarios or treated in the three different scenarios? Well, the most correct thing is then try to make a system enlargement. And what that means is that this heat, what does it do? Well, used as district heating, it replaces other forms of heating. So some material is combusted to produce heat that can be removed from your analysis. But not only that, you need to then analyze also the production of fuel. And this together is the system enlargement. So the emissions from this production of a fictive fuel and combusted and sent into district heating, this can be subtracted from your analysis. The second, after avoiding allocation according to ISO 14040, is to see if there are any physical connections between a production of two different things. This is basically only applicable in chemical industry. And it means that if you produce 100 of the first product and 20 of the second product, and if you just produce 101 and 19, there will be a significant and accountable difference. That is very seldom the truth. It's almost always something else in normal in industrial production, except for chemical production. So this is very rarely useful in other industries. The best thing perhaps is to try to look at it at economically based allocation. If we assume, for example, in the production of bottles, that this factory also produces windows for housing, what is then, how much of the total environmental impact should be allocated to the bottles and how much to the windows? And in this case, it is fair to believe that sometimes the industries are not very keen on giving out the economic data on this part. Especially in the transport industry, we have noticed that the transport companies are not very eager to produce economic data on how much they earn on different hubs and different nodes in the transport system. So this is also very difficult to use, especially in the transport industry. So the most common way is to use other kind of allocation, like weight or volume or energy intensity or whatever is relevant. And the result based on this kind of allocation differs very much. Can be very big differences if you use one of these others. So what the ISO 14000 suggests is that you do sensitivity analysis and look if the analysis differs very much if you use different kind of allocation methodologies. When you have done this, you get a full scale of the system boundaries that you need to assess. All of these boxes, you need to define and calculate all the emissions. And this is quite time consuming and very much on detail and data quality matter. It will mean a lot of subjective decisions as well. The next step, when you have done all these calculations, you will do an impact assessment. The first part of that is to classify and characterization. This is just a fictive result of the analysis of the three different scenarios: landfill, 80% glass recovery, or 90% reuse. If you get a result like this, where you actually can see the environmental impact from the three different in all kind of emissions, then you're fine. You don't need to do much more. You see that it's practically best to avoid landfill or glass recovery. Reuse is the absolute best. But it is seldom that this is the case. In many cases, you get a quite confused picture where one system is better on energy and less good on CO2 or hydrocarbons, etc. Then you have to try to do a classification of this impact. And that means that you characterize the emissions in the different acidification, eutrophication, and global warming, etc. When you do that, you get a much more comprehensive and better picture. But as stated in the previous film, if you're sitting as a constructor at Volvo, for example, and choosing between iron or alumina in your car, you cannot be expected to know, is it better to be low on acidification than on eutrophication? How much worse is global warming compared to acidification? You need a one-digit system. The alumina is 25 and the steel is 28 to be able to continue your work. This weighting results to a one-digit index is very much depending on the methodology, of course, and there are several available. This is three of the ones that is recommended to be used, and the first one is Eco Indicator 99. This is based on the different distance to target. That is, it's an assessment of an average damage in Europe, so it's not geographically, it's an average damage all over Europe, and the distance from the pollution to not having environmental impact at all. The second one is environmental theme, and that is the impact in the different themes that we showed you, the acidification, the eutrophication, and global warming. And then it is related to, for example, political targets, that we accept some pollution. It mustn't be zero. It can be accepted with some pollution, and then it's related to the political targets. The third one, EPS, it is based on a more monetary assessment. They have asked people how much they are prepared to pay for protecting the different safeguard subjects, that is human health, biological diversity, the ecosystem production capacity, abiotic resources, and finally cultural and recreational values. And as you can see, this is very much a subjective evaluation also, when you have to ask people how much are you prepared to pay not to have the ice melting in the North Pole compared to your recreational forests damaged. It's a very much subjective interpretation. But this is actually the only way to get this one digit, and it's not because of the methodology that the environment is complex. It's the environment that is complex, and that makes the methodology complex as well. And if we compare those three weighting models, you can see that it differs very much as well. In the EPS system, for example, you can see that the importance of CO2 is very much more important than the eco indicator, for example, which makes it very much difficult to have a clear view of it. So what the ISO standard and what the LCA methodology recommends is that you use at least 3 of those weighting models. And if they point in the same direction, then you are quite safe that this is the right way to go. And why is it so many weighting models? Well, it's quite easy if you just think about it yourself. What is your view of nature? Is that comparable with your neighbors or your friends? What is your view of human beings? Is that comparable with other views and values of humans? And what is your view of society? So, a system perspective like LCA, it is really complex. It is really can be blurry, but it is definitely necessary. Not having the system perspective, not having this perspective of it all, then you will be definitely wrong. While if you do this, you are approximately right. LCA is more of an engineering tool. It's not much of a natural science. It's an engineering tool. It's a compass to show you the right directions. You have to accept that it's a lot of subjective decisions. It's a lot of variations and low quality data involved. But it is a compass. It is a compass. And although you're only approximately right with LCA, not making LCA, that will make you definitely wrong. And it's better to be approximately right than definitely wrong. Thank you very much for watching.